everybody. Thanks for showing up. Thanks for being here. Hopefully I can help kind of clarify some cloudy areas for you. Just to give you a little background, I did actually write the prep path, the practice one, just so I had an idea of what you guys were going to kind of have to do and how much time you had to do it and what sort of materials you had. I was rather shocked that they would not allow you to use any paper, because I'm thinking, what if you have to write a number down that you want to remember and go back to? So I was kind of surprised, but I was a little nervous because I only teach up to grade 8, but I'm pretty confident that most of the areas that you are going to be tested in, I have a pretty good proficiency in. So we're going to go through a couple of different areas today, but then I'm also open to if you guys asking questions outside of what I'm going to share with you. I'll start my slideshow so that I have a guide, so I don't go off on a tangent and end up, I don't know, somewhere down the road and not where I want to be. So let me share my slideshow.
And Dee, if I'm going to jump in the chat,
Sure.
A lot of people are talking about the fact that you can use paper to some degree for sure.
Oh, can you see? I wrote a note down that it was that from the last meeting that paper was not allowed to be used. So that I was thinking that that's kind of difficult, but it's good to know that you can. Okay. Okay, so let's start at the beginning. Okay, so I came across a few really good resources for you to test yourself and prep yourself. I'm not sure how many of these you are knowledgeable of. Knowledge Hook, let's see if it'll take me there. Is basically based on the Ontario curriculum, and it does have all the EQAO tests, practice tests and questions in it. So it's taken a little while to load. I'm not really familiar with Zoom. I use Microsoft Teams, but I'll give you an idea of what it looks like. And you can create your own account for free. I think they let you do it for free for 30 days. And you can do one, once you start teaching, you can do it, you can create one for your students as well.
Okay, so Dee, you're going to have to click on share screen again.
Okay.
And pick the screen that shows your the website, I believe. Okay,
there we are.
There you go.
Okay, so I created like a class 2 proficiency. And if you go to the activities, you can actually go to grade 9 applied, you can go to grade 8, you can go all the way to grade 10 academic. And there's all kinds of kickoff missions where it gives you kind of questions to answer, multiple choice, and then it will show you the answer and how to do it. As well, there's some tutorials. So that's a really good resource. And like I said, it's free to join. Okay, I'll go back to my slideshow. One of my favorite resources I use with my students too, if they're stuck, they're at home and they're stuck and they can't get any help, Khan Academy. Is great. You can sign up as a learner or a teacher. If you sign up as a teacher, if you sign up as a learner, let me log myself in so you can see where I am. Oh, did I do my login name? I can do it this way. Too many accounts. Oh, there we go. Okay, so once I get here, there's courses I can choose from. So I chose like pre-algebra. You start it, the course, and it gives you all of every single expectation. So place value starts, be a little video, it'll show you how to do, he'll talk you through it.
Oh, sorry, somebody needs to mute.
So you got that idea. And then, if I close him out, oh, don't want to do that. Once you're done, you'll see that there's questions, writing, all kinds of different comparing, all kinds of different practice, all kinds of different videos to help you. So it's great because you can go through it. It tells you if you're right. It's self-paced. You can go back and watch the video again if you need to. Another resource is Math Antics, and Math Antics is basically just some video. It's a video. I'll show you what that looks like.
And while we're waiting, there was a question, is there a particular class code to input to access the content on Knowledge Book?
There is if you create it as a teacher, but you can sign up as a teacher, or I have created a class. So if somebody would like that information, I would gladly share it. And they can go on, and it's just set up to do grade 9 applied right now.
Okay, we got a yes, please.
Okay, so I'll send it out. So here, these are all the videos you can find on Math Antics. The only thing with Math Antics is that it is also American. So sometimes it's, I mean, the skills, the concepts are still really there. But if you want to look up like order of operations, he'll do a little video. He's quite animated. He's actually pretty funny. My students love watching him. But it's good because he shows it, it's visual. I'll show you a little bit of his video so you get an idea of what he's like.
Hi, welcome to Math Antics. Today we're going to talk about an important math concept called order of operations. Order of operations is just a set of math rules that tell you which math operations, like addition or multiplication, to do first. Now you might be wondering, especially if you're a teenager, why do I need rules to tell me which operations to do first? Can't I just do them in any order I want? Well, that's a really good question. And to answer it, we're going to give two totally different people the same math problem to solve. The problem is 2 plus 5 times 4. I like addition better than multiplication, so I'm going to do that first.
Okay, so you got the idea. Go back to my slideshow. Let me go back to my slideshow. So you can find any concept you're having trouble. He breaks it down. It's pretty simplistic, lots of examples, lots of different ways to go about it. So it's helpful. And then I'm sure most of you have heard of it, Microsoft Math. There's also an app called Photo Math. So you'll take a picture, you'll put the equation in, and it will show you actually step by step how to solve it. So if you solve it and you did something wrong, you can go back and see exactly where you went wrong. It'll break it down for you. So it's good to have if you're doing some practice questions and you want to check your work to see if you're doing it right, or if you know that you got the wrong answer, but you're not sure where you went wrong, it'll do step by step on how to solve any equation, any math problem. Okay. So as I went through a little bit of the previous presentation and I did the practice test and I looked up on the site about what your expectations are, I came up with a few tips that might help you as you're going through. So the first one is, it's important that you learn how the math works. So it's great to memorize a formula or memorize a procedure, but if you don't really understand how the math works, that might lead you to making some errors that you don't need to make or that you wouldn't normally make if you had a deeper understanding. So learning how the math works, and that's why I think the videos are great, because it really does break it down and show you step by step how the math works. That will help you build a deeper understanding. Not to mention, if you watch a video or you watch somebody do the math, it generally stays with you longer because you're watching and you're listening, so you're using two parts of your brain at the same time. Know that there's many ways to get to an answer and all are valid, but you guys are going to have a time restraint, so it's kind of important that you find the most efficient one, but the most efficient one that works for you, because one size does not fit all. So what might be efficient for one person might be completely confusing to another person, so it's important that you find a strategy, a method, a procedure that's going to work for you, that's not going to fail you. The other thing I noticed when I was reading the questions on the practice test is to make sure you're taking your time to read the question carefully. So I would spend a little bit more of my time reading the question to make sure that I know what the question is answering, because sometimes the wording's a little tricky and it's kind of making you, asking you to do the opposite of what it seems to be asking you. And if you're not reading it carefully, you might pick the answer that makes sense to you, but it might be the opposite answer of what you're supposed to be finding. EQAO does that a lot. It's important that you know your basic formulas. I know they give you a formula sheet, but if you have to flip around and look up the formulas, if you have to look up too many of them, it's going to take up a lot of your time, and then it's going to cut in on the time you have to solve. Do the questions. I tell my students this all the time for sure. Do the questions you know first and then go back. If you do the questions you know first, you start to feel confident about what you're doing, and it's likely it will activate your prior learning and it will help you with the ones you thought you were going to have difficulty with, because lots of times math leads to other math thinking. And so if you do what you know and you're confident and you're feeling good about it, then you're going to go into that question that you're having difficulty with more confidence, and you're more likely to be able to solve it. If you have to guess, do it strategically. I always tell my students, does that answer make sense to you? So look at the numbers, look at what you're being asked to solve for, and try and make an educated guess based on what number makes the most sense. For the pedagogy portion of a focus, I would say differentiated instruction is big. It's a big buzz right now too. It's something we focused on for the last few years, even with our board PD, different types of assessments, so assessments as for and of learning. So like a diagnostic, when do you do a diagnostic? When do you do a formative? When do you do a summative? Those sort of things are important to know. The purpose and the use of the assessment charts in growing success, there's quite a few assessment charts. So having an idea of when you can use them and what you can best use them for. And of course, IEPs are super important, because I feel like almost half my class is on an IEP some years. So having a really good understanding of what that IEP, what your responsibility is on that IEP and how you kind of roll that out is super important. Okay, I'm going to stop for a second because I've been talking a lot. Anybody have any questions so far, or anything?
Sure.
Lost you?
Yeah, so we've got a bunch of things that are coming through the chat. There's a whole discussion, which is very great. It's very rich, because a lot of participants have actually written the test in some cases, so they have some answers to some of the questions. So if you're following along in the chat at home, you can see some of the answers to some of the questions. So people were asking about, can you go back? And apparently you can go back as long as you're within the math section. But once you leave that section of the test, you can't go back. It's closed to you and you can't go back and fix things.
It does kind of remind you, as you cannot go back. If you hit this button, you cannot go back.
Right.
So
at the end of the section, I believe.
Yes, yeah.
Okay, and there was, okay, so, and the other thing that's come up, I understand that there was one invigilator who did stop people from using paper, but on the whole, the rules are that you can use paper.
Okay, that's good. I'll show you, because this was my paper when I was writing my assessment. See all the writing on it? That's my paper that I used. So, and I feel like I'm pretty proficient in math, and I still, that's how I do math. Like, I need to write my little notes down. I need to write my little figures down so that I know what I'm going back to, or I know what I need to, need to pull from. So yeah, I'm glad to hear that some will allow you, hopefully, because I think, yeah, some of it, especially like when you're trying to find multiple steps, it's nice if you can write down your one answer so you can go back to that. But yeah, but I was told that no, but maybe it's just that one, maybe just some of them, I don't know. Okay, anything else I should address?
Yeah, really quickly, the app that you were describing, Microsoft Equations, does that only help you with equations?
I don't know. I've only ever used it for equations, but it says, I think it says that it will solve any math problem. So I can't see why it wouldn't. Yeah, I think you can actually type in a word problem too.
Okay.
Yeah.
And I know we've had some requests, if you could give everyone a sense of, we are going to be doing some math and some
Yes.
examples.
Yep.
So people are anxious to get into that. And I've had a number of requests for work on slope and equations. So that's just
good.
what I'm following
The first
along
thing we're
with.
going to do is linear equations. That's the first thing we're going to do.
Right. And
Well,
I think I'm caught up here.
okay, so you'll all be happy because that's, yeah, that was the first thing because it came up a lot on Leanne's page. Okay, so my idea too is that student voice is important. So I want to make sure I'm hitting your content and I want to make sure I'm hitting your learning styles. So I'd like you to give me some feedback if it's too fast, or if I didn't cover something clearly enough, or if you need something a little bit more explicitly explained. I'm all for it. You're kind of like my customer, and I want to keep my customers satisfied. So let me know what's working and what's not working for you. Okay, let's do some linear equations and some slope and y-intercept. Okay, so the equation of any straight line is called the linear equation, and its formal formula is y equals mx plus b. M is basically the slope, or if you look on a graph, it's the line, how much the graph is going up by. So it's the rate of change. How much is it changing from the first to the second to the third term? So basically what's it increasing by or what's it decreasing by? And B is called the y-intercept, but it's basically just the zero value, or sometimes it's known as the constant. It's basically what did I start with and what am I now going up by? And so here's an example. Liam's going to the fair and it costs him $15 to get in and $5 for each ride ticket. So $15 is the B, or the y-intercept. It's what he has to pay. Regardless if he goes on any rides or not, he has to pay that $15 just to get into the fair. $5 is the M, or the slope. It's what his spending is going to increase by each time he buys a ride ticket. So $15 stays the same whether he goes on any rides. That $5 is per ride. That will change depending on whether he goes on 5 rides or 10 rides or 15 rides. So if Liam spends $45 at the fair, how many rides did he go on? The equation would be 5x, so 5 times number of tickets, ride tickets he bought, plus the $15 he paid to get in, and that's going to total to $45. Is that making sense so far? Okay, so that's the whole idea. It's basically a really complicated looking formula for something that doesn't have to be so complicated. If you break it down, it's just basically how much am I paying per ride ticket and how much did I pay to get into the fair? And that's basically all it is. And you think about it at any other real life situation. If you get into a cab, they charge you a fee for just sitting down. $3 to sit in my cab, and then they charge you whatever per kilometer. So that y-intercept is how much money are you going to have to put out, or what is the number you're going to start with, regardless of how many more things you do. Hopefully that's a little bit clear. Okay, we're going to try it. So Belinda is renting a moped to ride around for the day on her vacation. The moped's going to cost her $30 to rent, and then she's going to have to pay a fee of, a fee of $5 per hour. So what is an equation you can write to show the cost to rent the moped for any number of hours? So what's it going to cost her just to walk into the store and rent the moped?
It would be y equals 5x plus 30.
Good, perfect. So $5 per hour plus $30 to rent equals the cost. So 5x plus 30 is going to be her total cost she's going to have to pay out. Good so far? Okay.
And sorry, Hillary has her hand raised, so I don't know if
I can't see it. Sorry about that.
no.
Oh, it's because I
I'll
was
let you-
answering the question. Yeah.
Oh, that's
okay,
why.
thank
Okay.
you.
Yeah, just I can't see anybody's hand. I can see like 5 people in that bit. Okay, so here, so try this one. How much does it cost Belinda if she's going to rent the moped for 4 hours? Somebody want to share how to solve that?
We've got a lot of answers coming in the chat. We have a lot of 50s coming in.
Good. So
And
$5
Hillary.
per hour plus $30 to rent will give you her total cost. $5 per hour, 4 hours gives you $20 for the rental, $30 to take out the rental to begin with, so $50 is her cost.
And Dee, we will be sharing this PowerPoint with folks afterwards.
Absolutely.
Yeah, okay.
Yep.
So we'll send out links and files to everyone who had registered for this workshop afterwards.
Yeah, I'll look up what the Knowledge Hook class code is, so you can log into that if you want to try the grade 9 applied EQAO testing questions, and then the PowerPoint too if you want to go through it. And then we'll have all the links too. Okay, now we're going to go into writing an equation. So here's my pattern. What you want to come up with when you're doing a pattern, writing an equation, is you want to what's called a general term. So what's the rule of the pattern? But it's generally an algebraic expression when it comes to a linear pattern. So we want to write an equation or a general term so that I can determine how many blocks are going to be in any number. So if I said, well, how many blocks are going to be in my 7th diagram? I can determine that based on what I see happening in my pattern. So what I would do is I would create a table of values. So my first term has 5 cubes, my second term has 7 cubes, my third term has 9 cubes. I'm going to look for the difference between each pattern. And I can see that my pattern's going up by 2. So I know my 4th one will have 11 cubes in it. So my slope, what my pattern is going up by, is going to be 2x. When I need to figure out what my constant is or what my y-intercept will be, I need to go back to the 0 term. When I go back to the 0 term, I'm just going to subtract 2 from my first term. And so that makes my 0 term 3. 5 minus 2 is 3. So that means that 3 is my y-intercept or my 0 value. When I look at it on a graph, at 0 will be 3, and then my pattern will go in a line up from there at two increments at a time. So if I was asked to write a general term for my pattern, my general term would be 2x plus 3 will tell me how many terms in that pattern. So if I was going to look at my 7th term, if I was asked what's the 7th term in this pattern, I do 7 times 2 is 14, plus 3 is 17, and I know that in that pattern would be 17 cubes. And if you look visually, you can see that the constant or the 0 value is 3 because that's the color of the cubes. It makes it a little bit more visual. Is everybody doing okay so far?
I have one question mark in the chat, so I'm not sure what the question mark refers to, but someone did ask earlier about the colors, and I think you just finished explaining that.
Yeah. So the colors are to show you that the green is the 3, it's the constant or it's the y-intercept, it's what we started with, and then the orange is the pattern's going up by or the slope. It represents the slope.
Okay, and I had a question. Why did we subtract 2?
Because if we went the other way, 0 to 1 would be plus 2, but I have to go backwards.
Like, just first
Like 9 minus 2 is 7, 7 minus 2 is 5, 5 minus 2 would be 3. So you're kind of going backwards to find the 0 term.
Okay. And there was, I guess on the test, they were asked linear questions that we had to answer with graphs, not numbers.
They're coming up.
Okay,
We
perfect.
got graphs. Oh, look at that. A graph. Oh, ask and you shall receive. Okay, so you look at my graph. The general term you can write that. What general term can you write that describes the pattern? So I can find any term. This position only goes up to 5, but if I was asked what's the value of the 10th position, I can do two things. I could extend my graph if I had my graph in front of me, or I can look and see, okay, here's my y-intercept or my zero value. 4 on my y-axis is the 4, so that's my zero value. So 4 is my y-intercept. It's going to stay the same no matter how many terms are in my pattern. It's when I'm going to have to add on. And then I'm going to look for the difference or what my pattern is going up by. And my pattern is increasing by 5. So 5 is basically my slope. I go from 0 to 1, I go up 5, 1 to 2, I go up 5, 2 to 3, I go up 5. So 5x is my slope. It's what my pattern's going up by. So my general term for this graph would be 5x plus 4. And then if I put in any term, if I went 5 times 5 is 25 plus 4 is 29. If you look on the graph at 5, the value is 29. But the purpose of it is so that you can go to a value that's off your graph. So if I said, what's the 10th position number? I could say, okay, 5 times 10 is 50 plus 4, 54. In the 10th position, the number is 54. Another way is to create a table of values. If you're given a table of values and you're asked, write an equation based on your table of values. In this graph in particular, I don't have to subtract because it's giving me my zero term. My zero term is 1. So 1 is my y-intercept or my zero value. It's going to be tagged on to my equation. I'm going to look for the difference in my pattern. I know my pattern is going up by 2, so 2x is my slope. It's what my pattern is increasing by. So my general term would be 2x plus 1. And then if I said, okay, find the 15th term, I'll take 2 times 15, which is 30, plus 1, 31. So the 15th term's value would be 31. Everybody okay so far? Okay. Okay, so here is a little snippet from Khan Academy. This is the Pythagorean theorem intro, because that was one of the things people wanted to see. So I'll share the video.
Excuse me, I was wondering that table of contents. So that's where I failed my exam greatly. So those charts were the answers to the linear slopes. So the last 2 slides that you just showed, that that chart, one slide back, I don't know what you were just on, was what the answers had to be. I had 4 or 6 of them that had to answer to the slope. And that's how many I failed by. I literally failed by 6, and I've never known. And that was very fast for me. I don't know what you're saying. So I don't know where you're coming up with 2s and where those gaps are on that last slide to find the values, the table of values.
Okay, I'll show you, I'll go over it again.
Sure. That's what the answers. So on the MPT test last March, they asked the table of values. You had 6 table of values you had to pick from to be an answer to a slope.
Okay, so this is the table of values here.
Yeah, so I was given like, yeah. And I don't know, yeah, I'm not understanding where these numbers or where you're pulling numbers from. Like this doesn't make sense to my type of learning. So
oh yeah, no problem. I can, let me stop and back it up then. And normally on a table of values, you're not always given. I'm going to go back a little bit. You're not always given. I'm going to show you my original table of values that I created. So normally on a table of values, it kind of looks like this without all the writing. So let me go back. So if you look at this as my table of values that you're given, if you just look at the table of values there, 1, 2, 3, 4, 5, 7, 9, and it's saying to you, can you determine the general term or can you determine the slope of the pattern? What you have to do is you are going to look for the difference between each number. So the difference between 5 and 7 is 2, and the difference between 7 and 9 is 2. And so the pattern's going up by 2 each time. So that's where your
11. Okay.
Yep.
No
so
one's
that's where your
that.
slope
Okay.
comes from. You take that 2 and you put your X on it because X is going to be any term. X basically represents any term in the pattern. It could be term 1, it could be term 12. X is just like the unknown variable. So if you're asked, okay, what's the 478th term of the pattern, you can determine it using the general term.
So they would ask on the test, what is 2x, and then leave that blank. I've done the test, but I'm just the wording. That's what I'm not understanding. Like, so the 2x is 11. Is that the answer that you're saying right now?
No, the 2x plus, you need the 0 value, which would be 3. That means that if I go back to 0, there's 3 cubes that I would have started with before my first term. So your equation is 2x plus 3. So if they ask you, okay, what's the 6th term in the pattern, or what's the value of the 6th term, you would use your 2x plus 3. So 2 times 6 is 18, plus 3, 21. So the 6th term has 21 cubes in it. Does that help at all?
Yeah, I think I have a learning disability, to be honest. I'm not understand. This is something that I've never been able to get. I've had tutors months, and again, I'm signed up for months and I'm just not getting it. I apologize, sorry.
No,
Where's
don't
the
do
plus
it.
3 coming from?
Like I
Sorry to
don't,
interrupt.
yeah, exactly. That's where does this magical 0 and 3? Like that's not
Can
natural.
I
to me.
just, do you mind if I just step in for a minute? Because I understand, yeah, I understand where you're getting confused with all these letters and numbers and everything else. So I don't know if this will help you or not, if you don't mind. What Dee's found for us back at the beginning. So if you look at this, it's got term number and it's only giving you 1 and number of cubes that there's 5. So what Dee's done for us is she's just shown us if you go back to 0, which is on a graph, there's always a 0, right? And it's showing you that if you went back, your 0 would start you at 3. Does that make sense so far, what I'm saying?
Yeah.
Just thinking about the basic, just 0 is equal to 3. Okay.
Yeah, I didn't know where that came
Now-
from. Yeah, I didn't understand.
Yeah, so if you're looking at, so there's your graph at 0.
It's right there on the Y.
Your
it's
first part of
0.
it would take you to 3.
The 3 is
Okay,
the
and then-
y-intercept in the equation, y equals mx plus b. It's always b. Like the y-intercept is b in the equation.
Yep.
Did they ask
Is that-
you to find the equation or to fill in the missing numbers in the table? Sorry, can you clarify?
The one I wrote, they didn't have me fill in the number in the table. I don't know, some other people have, I only did the practice one though, so somebody who's done the actual one might be able to speak.
The actual test had a slope like this, and you had 4 table of values that was your answer, and you had to pick one. Many of those, like it was
Oh,
like,
you had to match the table of values to the
yeah,
graph.
yes, and a
So
lot
you'd
of,
have to find the slope first, and then you would
Yeah,
have to
yeah.
find the one that has the first differences correctly.
there was about 6 to 8 of them on everyone's test.
There were a lot
Well,
of
then,
people who
in
asked
that
me
case-
different things.
Yeah, so in that case, I would suggest that you do the same thing. You look for the 0 or the y-intercept. What's the number that starts at 0? And then you're going to look for what is the graph going up by? Because that's going to be your x. It's going to be whatever the graph is going up by, increasing by is going to be your 5x or your mx. And then 4, where whatever number is on the 0 will be your +4. It will be your constant. It's going to stay the same all the time, but the graph is going to continue to increase by 5 because the graph starts at 4 on the 0, on the x0. Does that help at all?
So, the 5, did you get that from doing rise over run? Like,
You know what, you could do it, but I wanted to keep it as basic as possible. And I looked at, okay, the first number is 4. The next number is 9. 9 minus 4 is 5. Then I'm at 9 and my next number is 14. 14 minus 9 is 5. So I did it just basic. Instead of trying to do division and rise over run, I just tried to do it the simplest basic way to determine it. You can do rise over run, but I think that if I did rise over run, that might be a little bit more complicated for people who don't understand it to begin with.
okay.
But absolutely, if you're confident in using rise over run, absolutely. I just kind of brought it back to basics so that you can understand where the numbers come from. Is that helping?
Yes.
Okay, so yeah, if they're showing you a graph, just look at what's the graph going up by and where does the graph start? What number does it start at? Like what number is on the y-axis? Like what number is on that y line? At 0, y, what is that number? And that's what you're going to add on. And so you're going to look for a pattern in your table of values that in this case, you would look for a pattern that goes up by 5, but that you still, so even if you think about it, x times 5 is just 5, but my first number is 9. So 5 times 1 is 5, but I have to add 4 to it if I want my graph to be on 9. Does that help?
Yes.
Okay.
And I'll just remind everyone, we will be posting a recording of this session later, so people can come back and watch it again. And as we said earlier, we will be sharing the PowerPoint and links after this. We'll be sending those out, but the PowerPoint will be posted through our website.
And if you happen to get a table that does have a 0 value, then the work's done for you for as far as what your B is going to be. You just have to look for the difference in your terms. So what is your pattern increasing by? And then where would it be if it was at 0?
Sorry, I have a question, if you don't mind. Can you just go back to the last slide, if you don't mind? Sorry.
Yep.
I'm just curious, because you're saying how the y-intercept, how it stayed the same, but is this only for linear equation? Because I don't think that would apply for non-linear.
Well, linear equations go up by the same amount every single time. So it depends on what kind of equation you're doing. Like linear equations are based on a pattern. There's all kinds of equations you can write based on anything, like how much money you're going to make, who's made more money. Even you use equations even when you're doing like area. If area is length times height and you know the area, but you don't know the height and you know the length, you can reorganize it, and that's still considered an equation because you're solving. An equation is just solving for an unknown.
Mm-hmm. Okay, thank you.
I don't think nonlinear equations are on the test, but I don't know if that's true or not. Like quadratic equations, like is that on the test?
I didn't see any quadratic equations.
Okay.
But I don't know, but like I said, I wrote the practice test, so I'm not certain. Okay, so I'll play this little video for you.
In this video, we're going to get introduced to the Pythagorean
Why did he stop?
theorem. Pythagorean.
This kind of gives you a little example of what Khan Academy does for
which
you.
is fun on its own, but you'll see as you learn more and more mathematics, it's one of those cornerstone theorems of really all of math. It's useful in geometry. It's kind of the backbone of trigonometry. You're also going to use it to calculate distances between points. So it's a good thing to really make sure we know well. So enough talk on my end. Let me tell you what the Pythagorean theorem is. So if we have a triangle, and the triangle has to be a right triangle. So it has to be a right triangle, which means that one of the 3 angles in the triangle have to be 90 degrees. And you specify that it's 90 degrees by drawing that little box right there. So that right there is, let me do this in a different color. That right there is a 90 degree angle, or we could call it a right angle. And a triangle that has a right angle in it is called a right triangle. So this is called a right triangle. Now, with the Pythagorean theorem, if we know 2 sides of a right triangle, we can always figure out the 3rd side. And before I show you how to do that, let me give you one more piece of terminology. The longest side of a Pythagorean of a right triangle is the side opposite the 90 degree angle, or opposite the right angle. So in this case, it is this side right here.
This is the longest side. The way to tell, figure out where that right triangle is, and you kind of, it opens into that longest side. That longest side is called the hypotenuse. Hypotenuse. And it's good to know because we'll keep referring to it. And I just so we always are good at identifying the hypotenuse, let me draw a couple of more right triangles. So let's say I have a triangle that looks like that. A triangle that looks, let me draw it a little bit nicer. So let's say I have a triangle that looks like that. And I were to tell you that this angle right here is 90 degrees. In this situation, this is the hypotenuse because it is opposite. It is opposite the 90-degree angle. It is the longest side. Let me do one more just so that we're good at recognizing the hypotenuse. So let's say that that is my triangle, and this is the 90-degree angle right there. And I think you know how to do this already. You go right, what it opens into, that is the hypotenuse. That is the longest side, the longest side. So that is the hypotenuse. So once you have identified the hypotenuse, and let's say that that has length C, and now we're going to learn what the Pythagorean theorem tells us. So let's say that C is equal to the length of the hypotenuse. So let's call this C. That side is C. Let's call this side right over here. Let's call this side right over here A. And let's call this side over here B. So the Pythagorean theorem tells us that A squared, so one of the shorter sides, the length of one of the shorter sides squared, plus the length of the other shorter side squared, is going to be equal to the length of the hypotenuse squared. Now, let's do that with an actual problem, and you'll see that it's actually not so bad. So let's say that I have a triangle that looks like this. Let me draw it. Let's say this is my triangle. Looks something like this. And let's say that they tell us that this is the right angle, that this length right here, let me do this in different colors, this length right here is 3, and that this length right here is 4. And they want us to figure out, that length right there. Now, the first thing you want to do before you even apply the Pythagorean theorem is to make sure you have your hypotenuse straight. You make sure you know what you're solving for. And in this circumstance, we're solving for the hypotenuse. And we know that because this side over here, it is the side opposite the right angle. If we look at the Pythagorean theorem, this is C. This is the longest side. So now we're ready to apply. We're ready to apply the Pythagorean theorem. It tells us that 4 squared, one of the shorter sides, plus 3 squared, the square of another of the shorter sides is going to be equal to this longer side squared. The hypotenuse squared is going to be equal to C squared. And then you just solve for C. So 4 squared is the same thing as 4 times 4. That is 16. And 3 squared is the same thing as 3 times 3. So that is 9. And that is going to be equal to C squared. Now, what is 16 plus 9? It's 25. So 25 is equal to C squared. And we can take the positive square root of both sides. C, I guess, just if you look at it mathematically, could be negative 5 as well. But we're dealing with distances, so we only care about the positive roots. So you take the principal root of both sides, and you get 5 is equal to C, or the length of the longest side is equal to 5.
Okay, we'll move on.
Now, you can use a
So the basic idea is that the one side, the square of the one side, the square of the other side is equal to the square of the hypotenuse. That's the theory of the Pythagorean. So, so in this case, this side of the blue side is 32 units squared, and the pink side is 32 units squared. So the large side, or the X side, the bigger side, should be 32 plus 32, which is 64 units squared. And then you just square root the number and you get 8. So the length of X would be 8. So in this case, what we're going a little bit backwards. So we know the hypotenuse is 44. and we know the one side is 33 square units, what would the other side be? If I know that 33 plus an unknown equals 44, I'm going to use the formula a squared plus b squared equals c squared. I know 33 and I know 44, so I'm going to put them into my formula, and then I'm just going to reorganize them because I want b to be by itself. So basically it's 33 minus 44 minus 33, and then b squared equals 11. And then I can test it, oops, and then I find out that 33 plus 11 equals 44. Did I go too fast or is that okay? So if you can think about it visually, you know that the two smaller squares, the square of the two smaller squares is the square of the hypotenuse. And then when you visualize it, if you know the hypotenuse, you can figure out the other two because you're basically then just subtracting them. So if we look at this here, we're going to find the hypotenuse. We know one side is 4 and the other side is 3. So if we use the formula a squared plus b squared equals c squared, a is 4 squared, b is 3 squared, and together they will give me c squared. So 4 times 4 is 16, 3 times 3 is 9. Together they are 25, but that's the square. That means that that big square, that big red area would be 25, but we want to know the length of the side, so we have to square root it, and c would give us 5.
Okay, Dee, I'm going to jump in here for a second
Yeah,
because
go
there's
ahead,
been a couple of questions. Some people are asking if you could slow down a little bit. But there was a question related to the test, and I think someone shared a screenshot of the calculator. So the question was, does anyone know if there is a square root function on the calculator?
There is.
There is. Okay, so that answers the second part of the question, is how would we calculate the square root without square root function?
The square root button, yeah.
Okay. So
I did do a little investigation for that.
Okay, perfect. Thank you.
Yeah. Yeah, because that would be a pain to try and square root things in your head, or no. That'd be a lot of guessing and checking. I don't know, what does it look like? Yeah. Okay, I'll slow down a little bit. Okay, so same idea. I'm going to give you guys some time to do it yourself. So we know the two sides, we know a and b, and we know that the formula is a squared plus b squared equals c squared. Let me give you some time to calculate it yourself, and then we'll take it up.
Can I ask a quick question?
Yeah, absolutely.
Okay, so I just got home from work, so I just kind of jumped in. But I do know how to do Pythagorean theorem. But the one thing that I was just looking at that you were showing, when I know how to do, like, say 2 and 10 and x here, but you had ones that said 33 and 44 or something units squared. So those ones were already squared. We don't then go ahead and square those. Those are done completely.
They're squared already for you, yeah. All you would have to do is then determine the square of the x. You just basically add those two together. And then you'd have to square root the other one, because you don't need the square if it's asking you for the line length.
Yes, okay, that makes sense, because the other ones technically weren't the line length, that was the square.
No, it was the square of the square. It was the square of the squares.
Yeah, okay, fabulous.
Square.
Yeah, no, okay, thank you, that makes sense, because I was just looking at it and I was like, wait, do I square those, or are they already squared? And I was like,
it's kind of a visual, so you kind of have an understanding of what a squared plus b squared equals c squared, like what it means. It's not just some random letters and numbers.
Right. Okay, no, thank you very much. That's very helpful.
No problem. Absolutely. Jump in. Anybody jump in anytime. Like, if I'm going too fast, just say, whoa, 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 because I do talk quite fast. I know that. I know that about myself. I am self-aware in that respect, but sometimes I get, I get so excited about math, I forget to slow down that. So I have my students always tell me all the time, whoa, 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 back it up a little bit.
Sorry, Dee, just to kind of go off from someone's previous question in regards to when you're going backwards, so let's say you're not trying to find C this time because you have C, but you're trying to figure out, let's say B, for example, you don't have to square root unless it's C that you're looking for, which is the longest part of the triangle.
No, you'd have to square root them all because they're all squares to begin with.
Oh, okay, gotcha. Okay.
Right? They're all exponents. They're all squares. So whether you're looking to find A or you're looking to find B, you're going to have to square root them unless they're asking you for the square area. But generally on a test, they'll probably ask you for what is the unknown length. And in this case, the unknown length just happens to be the hypotenuse. But it could be, and I have a couple of examples where maybe we know the hypotenuse, but we don't know the 2 in this particular triangle. Or maybe we know the 2 and the hypotenuse, but they haven't given us the 10. So you have to just be able to move that formula around to understand. And that's why I did the squares, because to understand that the a square and the b square together make the c square, then you know that if you have the c square, you just subtract the other number that you do have.
Yeah. Okay, great. Thank you.
No problem. Do we all have an answer? Have we solved?
We have one answer of 10.19.
Okay, so A is 2, so 2 times 2 is 4, and B is 10, so 10 times 10 is 100. 4 plus 100 is 104, so C squared is 104. Square root it, 10.2. Now, I don't know if in the test, sometimes with decimals, they will just leave the number as the square root of 104. So that's what I mean, like the trickiness sometimes. Like even on some of the knowledge hook questions, if the square root's going to be a decimal, then they'll just leave it at, okay, the hypotenuse is the square root of 104. But it's always good to be able to find it anyways. Either way, the answer will be in your work. Did everybody get the right answer?
Most of them did. I would say a high percentage.
Okay, good. Okay,
Just
we're going to do another
clarify.
one.
Can I just clarify something? Every time you're
Absolutely.
looking for an unknown element in the Pythagorean theorem, you're always square rooting, regardless of whether it's A, B, or C?
Yeah, if you're using a squared plus b squared equals c squared, absolutely, yes.
Okay,
So
thank you.
even if you're looking for the a in the formula, you're going to have to square root it. If you're looking for the b in the formula, you will have to square root it to find it. And you'll see that I have another example where you'll see that. Okay, so here is a perfect example. I know the hypotenuse is 13, and know that a and b are interchangeable. It doesn't matter what you call a and b because combined they are c squared. So it doesn't matter if you call 12a or you call 12b, or if you call xa or you call xb. It doesn't matter because you're adding the two together regardless. So it's going to be the same. So think about the formula, a squared plus b squared equals c squared. And we're going to want to reorganize it because we already know c squared. We just have to take away the b squared to find the a squared. And I'm going to give you a couple minutes to solve that on your own as well.
Getting some answers coming in already. We seem to be getting the number. Shall I share it? Is it too early?
Is it too early? People still working on it?
Well, and there's a question here, and it's interesting. If you look at your triangle, you can pretty much, I don't know if they're going to be very tricky about this, but you look at this, the length of your hypotenuse, which is the longest side, which is 13, and you know one of the other two sides is 12, I think you should be able to guess or have a reasonable idea of how big the other side is. It's going to be smaller than the longest side. So it would be helpful. I know some people are asking the question, they've come to an answer of 25, and then they're wondering if they should take the square root of 25. And I'm just thinking that if 13 is the longest side on your triangle, it's got to be smaller than that. So I'm guessing you're going to have to take the square root of 25 to get you to 5.
That's good. That's right back to the idea of like, think about the reasonableness of your answer. We know that the hypotenuse is the longest side. So that number, the hypotenuse, always has to be bigger than the other two numbers. Does anybody want to share how they solved? Is anybody feeling confident? And
Could I ask a quick question just about why we brought C over to the left side instead of the other way around, where we didn't bring B over to the right side?
you could have. It doesn't matter how you do it. I was just because
Oh,
when you look at the big picture, you looked at C is the biggest one. And if I know another side, I'm just going to subtract that other side from my C. So that's why I kept it that way.
would I get the right answer if I would have done it the opposite way though and brought the B over to beside the A and maybe I'm
It
mixing
would have
myself
still
up.
been, it would have been A squared equals C squared minus B squared, which is the exact same thing. It's only the order, they're still equal. That's the idea, right? It doesn't matter which side of the equal sign they're on, as long as you have C squared minus B squared on one side and A squared on the other side, it doesn't matter which order you put them in. Does somebody want to solve? I can't see if anybody's hands up.
Yeah.
I could. Oh, they can do it.
Can I talk?
Yeah.
Okay, Janet, why don't you go ahead?
Yeah, okay. I just want to mention something. Like, do you see like the formula is like A and B and C, and the graph it's like X? Maybe some student they're gonna be confused, like for X, maybe you put C. I'm just like asking for that. Or
Well, it wouldn't be C, it would be A or B.
yeah, like
I think
13. Yeah, know what I mean?
A reason they use X is because it's a standard for an unknown variable. And right now that's the unknown in the problem.
Okay.
And
So-
Valentina
That's
has
how
her
it's going to
hand.
show up on your test, because it won't show up. It's not likely it'll show up as what's the value of A or what's the value of B or what's the value of C. It's unlikely.
Okay, so can I solve the question?
Absolutely.
So we can say x squared plus 12 squared equal 13 squared. So x squared plus 144 equal 169. So we're gonna move 169 minus 144 equal x squared. Then x squared is 25. So root square of 25 is 5.
Okay.
Yeah.
Yeah, you just reorganized it after you put
Yeah.
the values in, which is fine.
Yeah, okay. Thank
Yeah.
you.
Okay, are we good so far?
I think so.
So the unknown variable always has to be on its own, right? That's how we know that we're putting the variables in the correct order.
Yeah, and that's some of the basis of equations and solving equations is to isolate the variable. You want the variable all by itself, and then that way you can solve for the variable. Whatever math you're doing will lead you straight to the unknown or the variable.
Thanks.
Yeah, no problem. Okay, find the value of X for this triangle.
Now, Dee, there is a whiteboard feature in Zoom.
Okay.
And if somebody's made the request, can you do this on the whiteboard slowly, please? So to do that, and I know you're not familiar with Zoom, but if you're willing to take a leap here.
I'll take a risk. Let's see. I don't know how
Okay.
well I can write on a whiteboard on my laptop, but I'm willing to give anything a go.
Okay, so if you go to your share screen button, and one of your choices should be the whiteboard.
Oh, I see it there. Okay. Okay, so you're gonna,
So you're sharing your whiteboard right now.
okay, so let's see how this works. Oh, I can't draw with my mouse. Let me see if I can draw with my finger. Oh, that's
Oh, that's
even
much
worse.
better.
That's not good. That's not good. Okay. Need a little more practice with this. Okay, so here's my triangle. Woo, I'm not as good as Joe Khan Academy. He's much better than me at this. And if I can remember what my values were, what were my values? Somebody have the values written down?
9. 9 is the long side.
Hypotenuse is 9.
The short side is 4.
Okay,
And then X is the, it's like the other side, I guess.
whatever it is. Okay. Okay, so because this is my hypotenuse, this is my c squared, but unsquare rooted. And then I have my x, so it'd be my x squared in my formula plus 4 squared equals c squared, but c squared in this case is 9. Oops. Nope, nope, not what I wanted. Oh, I'm gonna have to do some whiteboard practicing, man. This is tough.
And we
See,
put
I
you on the
should've done
spot.
primary and I could have been on a smart board all the time.
Isn't it 9 squared?
Yep.
Okay, just checking.
It might take you longer with the whiteboard.
Pardon? It's gonna take me long with the whiteboard?
Yeah.
Yeah, well, yeah. I don't know if it's helping. Is it helping at all?
Yes.
Okay, so anyways, I'm going to move this basically to the other side so I can get my x all by itself. So now my x squared, which would be my a or my b, is going to equal 9 squared minus 4 squared. I should have kept my stylus with me. So then x squared is going to equal 9 times 9, which is 81, minus 4 times 4, which is 16. So my x squared is going to equal
65.
Thank you. Don't want to mess up my math here. You guys will all make fun of me. Okay, so that's x squared, but then I have to square root it. So x is going to equal, drum roll please.
8.07.
$8.06. Does that help? Wow, that's a mess. That looks like one of my students' answers.
Awesome.
Are we good with the idea of it?
Yeah.
Okay.
It helped a lot. Thank you. And a question about rounding. So,
Question about rounding?
yeah, I guess, when do you round?
Generally, it'll tell you to round. For the most part, it usually tells you to round to the nearest hundredths place, which is 2 places after the decimal. So you would look at the third number. So in my case, in this case, it was 8.0662225222577. So I would look at the 6 and the number next to the 6 is a 2. So it would stay a 6. If the number next to the 6 was a 5, it would change to a 7, 5 or higher. Rounding rules seem to be difficult for people. I think that the whole idea of that if it's below 4, it stays the same. And if it's above 5, it increases. And people kind of mess up, what does that mean by increases or stays the same?
Okay. And Joy Raven, we are going to be providing a link through this session, so you'll be able to see what was written. So just someone was asking to go back, but I think we're running out of time. So we're at 5:08 already. So I'd like to keep moving forward if we could.
Okay.
And I apologize to Joy Raven.
Okay, so okay, so then you might see something like this. So it's basically find the value of X in the isosceles triangle below. And in this case, the X would be the hypotenuse of the two triangles. So that would be the hypotenuse of the triangle. Because the line's going down the center, that makes that a right angled, basically makes it two right angled triangles butted up against each other. And so X represents equal sides because they're both X's. That means they're the same value. But the base of the triangle is 10. And because the base of the triangle is 10, but we really have two triangles, we know that each triangle's one side, A, is worth 5 because it would be half of the 10 because we're looking at half of the triangle. So in this case, A squared plus B squared equals C squared. A squared would be our 5, so it'd be 5 squared. Our B would be 12, so 5 squared plus 12 squared equals our C squared. And because both values are the same, the answer will be the same. Do you want to give that one a go?
We got a bunch of answers coming in. They seem pretty consistent.
Well, that means that it's starting to, you know, get in the groove of it.
Yeah, and I will note that the number they're sharing is larger than 12, which sounds reasonable to me, because if it's the hypotenuse and it's the longest side, it would have to be longer than the 12.
Exactly. That's a good connection.
So I'm seeing a lot of 13s as the final answer.
Oh, that's a good sign. Does somebody want to share their solution?
Janet would like to try.
Can I?
Yeah.
Okay, so we can say x squared equal 12 squared plus 5 squared, which is 144 plus 25. That's with x squared. So x is equal 169 under square, so which x equal 13. Yeah.
Good work.
Thank you.
Good job.
Thanks.
Okay, now here's one where I was telling you where the hypotenuse is left as a square root. So basically, you're looking for the square of the number. And in this case, the 8 is the base of the triangle as well. But we have two triangles butted up against each other. So that means each side length would be 4. So it would be 4 squared plus x squared equals the square root of 20. So see if you can do this one. It's a little trickier, but it's just basically what they did is, because it's a decimal, they didn't square root the 20. So you're going to get all the way down to where you would square root, but you'd stop there.
And we're starting to see some answers coming in.
Awesome.
But we have some disparity between our answers.
That's okay. Disparity makes for good conversation.
And again, the answer would have to be, based on the side being 4, would have to be greater than 4 because it's the hypotenuse?
No, we know the hypotenuse. The hypotenuse is a square root of 20.
That's right. So the square root of 20 is greater than 4 then.
Greater than, yeah, greater than 16.
I will stop talking now because I obviously am confusing me myself.
Well, if you even think about it simply like the one side is 4, so 4 times 4 is 16. 16 plus what gives you 20?
Okay. And we've had a number of people answering 4, but I've also had 2s and 3.5s. So we've got a variety. So I'm sure we're going to have to look at the process to follow here.
And I can understand the 2 and the 4 being mixed up because we're looking at a square root of 20, but we're looking for the value of x. We're looking for the side length. And if you have it's the square root of something, then it could be the right answer. But if you don't, if you have it as an actual value, it would be a different answer. But both answers would be correct.
People are changing their answer to 2 now.
Was it something I said? Does somebody want to solve? Is somebody feeling?
Yeah, I can do it.
Is it 4?
No, it's 2.
Oh, it's 2.
Yes, right?
All right, Janet, go for it.
Okay, so gonna start like, first of all, when 20 underscore, when we square it, it's gonna be same number, it's gonna be 20. This is the first point, right?
Right.
And okay,
It's 20.
yeah, so x squared plus 4 squared equal 20. So x squared, yeah, plus 4 squared was like 16. So we can say like a 20 minus 16 equal x, which is x squared equal 4. So then x equal 2, right?
Right.
Yeah.
So basically that 20 stays there because you don't have to square it because it's already squared. And then you're just going to subtract the 4 squared away from it. So 20 minus the 16, which is the 4 squared, is going to give you 4, but that still represents the a squared. So then you square root it. And that's why I said if you had the a squared is the square root of 4, you would be fine. But if you want to know if it wants the actual length, it would be 2. And the reason for the square root of 20 is because if you square root 20, it's a decimal. And that prevents you from having to work with decimals.
So why are we not square rooting the 20 right away?
You don't have to square root the 20 because basically 20 is c times c already, which you would do normally. That's one of the first things you do, right? Because it's a squared plus b squared equals c squared. So the first thing you do if you knew the hypotenuse was square it, and the square of the hypotenuse is 20.
The square root of 20 is 20, right? Like the square root of any number is always the number itself. Is that right or no?
No, square root
No, it's not.
is 2 numbers that you multiply together to get a number. So like 4 times 4 is 16. The square root of 16 is 4.
Oh no, but I mean, maybe I'm not saying the right word, but like the square root sign, like let's say it was like what if it,
the square of the number and the square root is the same?
like what if it had 5 inside the 20 on the hypotenuse angle? Would it also be 5? Like I thought the rule was because you're trying to square, 20 squared, right?
Yeah, so basically the hypotenuse is telling you what its square is. So it's saying that my square is 20. And then the other square, the other two smaller squares, one would be 16, 4 times 4. And then you'd have to find the other, the x, which would be 2 times 2.
Oh, okay, yeah. So it's doing that instead of giving the decimal number, right?
Right, exactly. So that you're working with a whole number as opposed to working with a decimal.
Can I ask a quick question?
Absolutely.
So I just kind of went for it because I wasn't really sure with the square root, like the 20 square root. And so I think I did it correctly and I was listening to what the other girl said, but I didn't realize that when you do, so I have written here, x equals square root of 20, subtract 16. That's because I rearranged it a little bit differently.
Yeah,
anyway, I didn't know that when you have a square root like that, I don't know if I'm going to explain this correctly, but anyways, I feel like you just take away kind of like the square root sign, you subtract 20, like 16 from 20, and then you put it back.
Yeah, the idea of the square root on the 20 is so that you're not doing a decimal times a decimal. So basically c squared, the value of c squared is 20. Where in the other ones you would then square root it to find the c. In this case, they're already giving it to you and they're saying that the square of c is 20.
Okay, I guess what I'm trying to say is like if this was not a Pythagorean theorem question,
right?
It's just like, hey, find like x equals square root of 20, subtract 16. I'd be like, do I just subtract 16 from 20, or is there some special rule because it's a square root? But you just literally subtract 16 from 20 and it's square root of 4.
Right, because the one square is 16, it's 4 times 4. And the other square is 20. So one square, the hypotenuse is 20, and x plus a plus b is going to give you 20. We already know the other one is 16. So the square of the x has to be 4. And then you would square root it to get to 2.
Got it. Okay.
I think we're talking the same language, but maybe I totally missed. Does that make sense?
No, that's okay. Yeah, okay. It does. My question is kind of like unrelated to Pythagorean theorem.
Okay.
So anyways, it was just that one little part of the equation. I was like, what do I do? Do I subtract 16 from 20, or do I have to find the square root first? Because can you do that with a square? Like, can I just subtract the number underneath it and it becomes a 4? Like, I just didn't know that that was the rule.
Yeah. Yeah, because basically all you're doing is instead of squaring c, you're already starting with c squared. You're already starting with the value of c squared.
Got it. Okay, thank you very much.
Okay. Can I ask some comment? Yeah, like any number when we have a root square and when we try to square it, so the root square is cancel the square. So it's gonna be same number. I don't know, like, do you understand what I say? Like when we have 20, the root square of 20, right? And when we try to square it, so the square is gonna cancel the root square, so it's gonna stay the number. That's right. That's what I learned.
Yeah, the square root is just there so you know that that is the actual area of the square. So that actually, that square root 20 represents c squared, the value of c squared, which is 20.
Dee, would it be useful if we did another example where we did a number that everyone understood the square root of, like 16? So if we did the square root of 16 as your hypotenuse in another example.
There we go. Absolutely.
And then maybe people would be able to visualize what it looks like.
Oh, yeah. I just don't have another question like that, but we can make one up. Try doing it with, this, the square 20, the square root of 20 being 16.
And still keeping the value of 4 at the bottom?
Yeah.
Okay.
Sure, why not?
Square root of 16, that's what we're replacing it with?
Yeah, so the hypotenuse will be the square root of 16. And everything else the same.
Would that be 16 minus 16?
Unfortunately, yes, it would be.
So that's a really bad
I'm looking
example.
at this going,
Just so you know, I didn't pick the 16.
I just thought it would be an easy number. Yeah,
Maybe you
my
should have done
bad.
25. Try 25.
Well, I'm
Yeah.
glad I figured it out anyways.
You got it. You're on it. Yeah, if you do 25, that might be a little bit easier.
Yeah. Yeah, okay, good. That's a more elegant one.
There you
for
go.
sure.
But then you'd have to find the square root of 5, which would be a decimal, but it wouldn't matter. You got the idea of it. I just wanted to throw it in there just in case something like that shows up, that you know that if it shows the square root, the hypotenuse as a square root, or one of the A's or B as a square root, that number's already been squared. You don't have to square it. It's in its squared form.
Yeah, so I believe the answer is 3. 25 minus 16 is 9, and the square root of 9 is 3.
You got it. Much better than 0. A non-line.
Maybe. Yeah,
Okay, well, that's the end of my slideshow. Does anybody have any other questions or any tips or any suggestions for the my next presentation, my next session? A little bit of feedback on like what went well, what needs to change. I'm open to suggestions. This is new for me. So yeah, I'm open to ideas.
So to answer some of the questions that are coming in, there are many different presenters who've agreed to work on office hours. Dee's coming back for sure for at least one more session.
Yeah, I think it's June 16th I come back.
Okay, and so people are bringing up all kinds of things like ratios, order of operations, bed mass, fractions, percentages, ratios in geometry, everything, I guess, really. So every time we have a session, they are on Wednesday nights and they run right through to August for those who are interested. I'm trying to answer some questions while answering your questions too. Word problems, ratios, time, distance, speed questions.
Rates, the rate.
Probability. Thank you so much. This has been helpful. Wow, thank you. This has been helpful.
Oh, that's awesome.
Yeah. Light bulb.
I'm gonna try and like check in on the other presenters to kind of see what's being covered, so it's not all duplicated. So I will kind of check in to see what's being covered. But like I said, I'm open to suggestions too if something's not being covered or you feel like something is missed. Yeah, I'm more than happy to cover whatever I can to help you guys.
I have one question. So when you did the linear equations was sort of the confusion point for me. And a lot of the questions in I haven't done the regular test, but in the practice test, it asks you a lot to identify on the graph. So it'll give you an equation and then you have to find it on the graph.
You have to find the graph that matches the equation, or you have to find
the graph that matches the equation.
Okay.
And the confusion part the part for me that was confusing was I always thought that like the y-intercept to the left would be negatives and to the right would be positives, sorry, the x, and then below the center line would, and they always want you to explain where the axle point is, and I get so mixed up. I have no idea like which graph suits.
Yeah, because I didn't really cover a graph with a positive and negative. I just covered a positive, like the graph that I used was just positive numbers.
Yeah.
So
a lot on the practice test. I don't know if there is on the regular test.
Yeah, so it would be the same thing though, but instead it would be a subtraction. So if you end up on the y line, if the number on the y line that is at the 0, the x0 on the y line is a negative, then your constant or your b would be like minus whatever that number is. So if you're going down the graph and you end up, say you end up on the dot is right on the y at -3.
Yep.
Then your constant or your b, instead of being a plus, would be a -3.
Okay, so it's where the dots are that you're looking for, not where they line
It's
to.
where the dot is on the y line. So where that dot ends up on that 0.
Okay.
So look at the line, the y line, and look for the dot that's actually on that line. And look at the value of that dot, and that will be your constant. That'll be either a positive whatever or a negative whatever. If it's a negative, then you're subtracting that. And then the only other thing you have to look at is, what is the graph going up by? Like from 0 to whatever. Just look at the intervals of the graph. So
Yep.
are the lines going up by 4 each time? Is it going from like 3 each time? And that's the only things you're going to need to know. That number that is changing, that is the same but changing, like +3, +3, +3, that is going to be your 3x.
Yep.
And then look for the dot on the y line. That dot will be your constant. So it'll either be, if they're doing a double, like a positive negative graph, then that will be your y-intercept, or your plus, like your plus or minus constant.
Okay.
Does that help at all?
Yeah. I think it's just, I think I'm gonna go on the websites that you gave and have a look, and then I might have a more exact question or example, but
okay,
it's more identifying it. Like I had no idea, because it's like they're both hitting points that represent the thing, but I couldn't tell to what angle the line should look. Does that make sense?
So what you want to look for is in your table of values, what is it going up by? And your graph should be going up by that same number.
Okay.
And then you want to look on your y line, and wherever that dot is on the y line, that should be your B.
Okay. Thank you.
But yeah, check Khan Academy. He does a lot of like you could see, even when we did the Pythagorean theorem, he does it really slow, really methodical. He's really repetitious. He's got kind of a calm, night talking voice. So he's not like me. He's not hyper and spazzy. So he's, he might keep you a little more calm. And then he does, like I said, he'll do a bunch of examples. And then there's a bunch of practice questions you can do, and you get instant feedback, right or wrong. And then there's also a tips. You can hit the little tips button if you're not sure how to answer it, and he'll give you a hint on what you need to look for. So it's really good. I use it with my kids that are struggling because as a reinforcement, because sometimes you have to see something. I know for me, I was terrible in math when I was in elementary school. I almost failed grade 3 because I didn't know my multiplication table. And it wasn't until I got to high school and I learned how to do math my own way. I learned how to understand the math, and then they moved me from applied math to academic math in grade 9. And I soared from there. So it just goes to show you that just because the math seems difficult doesn't necessarily mean it's the math, and it doesn't necessarily mean it's you. Sometimes it's just the approach somebody took to teaching you it, and you didn't get that deeper understanding, and you don't know why these formulas work. Like, they're just a bunch of numbers and letters, and they don't make any sense. So that's why I said at the beginning, you have to let the math make sense for you. You have to be able to figure out, you have to know how the math works. If you can figure out how the math works, you're gonna skate, I promise you. But it's just, sometimes it's just taking that time to watch it over and over again, or do a lot of practice so that it comes to you naturally, and it's like, oh yeah, and you'll be like, oh yeah, that makes sense, that totally makes sense now. And that's exactly what I had to do for myself. Otherwise, I probably would have flunked out of math in high school.